Hello and welcome to Functions Reflections Practice. So let's get straight into it. First question asks, for each question, state the parent function and determine whether the function is reflected horizontally or vertically. So let's start by stating the parent function out. So we have a first function here, which is f of x is equal to minus square root of x. So the parent function for this one is going to be the base function y is equal to the square root of x in its base form. And now we have to determine whether it's reflected horizontally or vertically. So what I'm seeing here is the negative is on the outside of everything. It's being multiplied into the square root of x. So that means it's going to be a vertical reflection down. So you could say it's a vertical reflection. In other words, the negative's on the outside. So all our y values are being multiplied by a -1. So it's being vertically reflected. Let's move on to B. Let's determine the parent function of this. So the parent function, I think, is just going to be the base form of the logarithm. So we're going to say y is equal to log of x. It's the simplest version of the logarithm function. And now we have to determine whether it's being vertically reflected or horizontally reflected. Now what I'm seeing here is there is no negative here. So that means the negative is inside the x. So that means we're having a horizontal reflection. Sorry. So we're going to say horizontal reflection because the negative is on the inside. That means we're multiplying all of our x values by -1, which we're going to have a reflection across the y-axis. So let's move on to C. This looks like our parent function is going to be the base form of the cosine. So we're going to say y is equal to cosine of x. This is the simplest it can get. And I think this is also going to be a vertical reflection as we saw up here because the negative is on the outside. In other words, we're multiplying our negative into our whole entire function here. So all our y values will be flipped. So you can just say it's a vertical reflection. And lastly, I want you guys to give this a try. Pause the video if you need. 3, 2, 1. And the parent function for this is going to be just y is equal to the absolute value of x. And it's going to be a vertical reflection because the negative is on the outside. So we're going to say vertical reflection. Okay, let's move on. Questions 2 states, given the equation f of x is equal to whatever this is, write the equation of h of x equal to minus f of x. So we'll start by writing our function h of x. I'm going to use blue here. So we have h of x. And it's just basically f of x, but everything's being multiplied by -1. So we're actually going to sub this negative into our function f of x. So we're going to say equal to, since this negative's here, we're going to multiply our entire function by f of x. So we're going to do negative times x cubed. We're just plugging this down here. X cubed minus 2x squared plus 4x minus 7. So all we did was we wrote h of x, and basically h of x is our f of x function, but we're multiplying it by -1. So we can distribute this negative now. We can say h of x is equal to minus x cubed minus, plus 2x squared minus 4x plus 7. So we've written the equation of our function h of x, and just to be curious, this is actually a vertical reflection. So h of x is a vertical reflection of f of x because the negative is on the outside here. Let's move on. So question 3. The functions f, solid, and g are dashed and graphed. So there they are. F is defined to be this function, and what is the equation of g? So in order to solve this problem, we have to figure out what transformations are applied to g. And it looks like I'm seeing a vertical reflection here because all our values are being vertically reflected. Because f, this point normally it's at -8, -5. It's now at -8, +5. So we have a vertical reflection. Let me write that in. Use a different color here. Vertical reflection. So that would mean that our g of x function is just our f of x function multiplied by -1. So we can say g of x is equal to minus f of x, because all we did was we applied the vertical reflection to our function f of x, and that's going to be our g of x function. So we can expand this out since we know our f of x, so we can say g of x is equal to minus times 3 times 2 to the x minus 1 minus 5. So we can distribute the negative in now. Use a different color here. Distribute this negative. And we're left with, use a different color. Choose blue shirt. G of x is equal to negative 3 times 2 to the x minus 1 plus 5. So there we go. We've written the equation of g of x, which was essentially just a vertical reflection of f of x. We've shown that through these steps right here. Let's move on to the last question. It asks, given the function g of x is equal to the absolute value of x minus 3 plus 2, determine and sketch the graph of f of x is equal to minus g of x. So what we have here, let me just write this in, g of x is equal to the absolute value of x minus 3 plus 2. So we have this function here, and we're asked to sketch the graph of f of x. So is this going to be a vertical or a horizontal reflection? Now, since the, we use a different color here, since the negative sign is inside the x here, that means it's going to be a horizontal reflection, or in other words, across the y-axis here. So what we're going to do is we're going to first answer part A of the question, which is determine the equation of f of x. So we're just going to write f of x is equal to g of minus x. So we're going to apply the negative inside the x here. So we're going to say negative times x minus 3 plus 2. And all I did was I applied the negative inside the x, and in this case, the x minus 3 is all basically the group inside the x. So there we go. We can expand this if we need, so we can say f of x is equal to the absolute value of negative x plus 3 and plus 2. There we go. We've distributed the negative inside the x, and that's our function f of x. Now, answer part B, all we have to do is apply a horizontal reflection to this function here. So I'm just going to keep the y values the same, but I'm going to reflect them across the y-axis. So I'm noticing the point is at 3, 2. So the point 3, 2. That's going to be reflected all the way across the y-axis, so it's going to be at negative 3, 2. So it's going to be at negative 3, 2. Notice how we're keeping the same y value, but we're just multiplying our x values by negative 1. And for this point, it's at 1, 4. So that's right, 1, 4. This is going to be reflected across into negative 1, 4. So it will be right there. And we can do the same thing for here. This is at 5, 4. Now it's going to be a negative 5, 4. Right there. Let's keep going. This is at what's that? Negative 3, 8. That's going to be at, let me write that in, negative 3, 8. We're going to multiply our x values by negative 1. This turns into a positive 3, so we're going to go to positive 3 eighths right there. And there we go. And now let's just do one more point just to be safe. Let's do, for example, 9, 8. This will be at, this is 9, oops, not g, 9, 8. This will now be at negative 9, 8. So right there. Let's connect the dots now. Include the arrows. And we've written our function f of x. F of x is equal, probably should do that a bit lower. F of x is equal to g of minus x. There we go. We've answered the questions. See you in the next video.